Welcome to EKS and Kubernetes for Beginners. I'm Bo Carnes and I'm teaching this course. Throughout this course, we'll be working with this real-world example application, the Zephyr Archaeotech Emporium online store. This is a modern microservices-based application. This application represents a realistic scenario you might encounter in production environments, making it perfect for learning Kubernetes deployment patterns. We'll be using Pulumi as our infrastructure as code tool to manage our EKS clusters and deployments. Pulumi offers several advantages. You can write infrastructure code in familiar programming languages. There's strong type checking and IDE support. It has built-in state management and has excellent support for AWS and Kubernetes resources. Pulumi provided a grant to make this course possible. First, we'll learn about Kubernetes. Well, what is Kubernetes? Kubernetes is a container orchestration platform that revolutionizes how we deploy and manage modern applications. To understand its role, let's start with the basics of containerization. Applications are often packaged into containers. Think of these as complete portable packages containing everything needed to run your application. While containers solve the packaging problem, they introduce new challenges in management and deployment at scale. This is where Kubernetes steps in. Think of Kubernetes as an operating system for your cloud infrastructure. Just as Windows or Linux or macOS manages the resources and runs applications on your computer, Kubernetes does the same for your containerized applications across entire data centers. It makes complex decisions about where to run your containers, how to connect them, and how to ensure they're running optimally. So why use Kubernetes? Well, consider this restaurant analogy. Running applications without Kubernetes is like managing a restaurant where you personally handle every detail, seating guests, taking orders, and coordinating with chefs. It's possible, but becomes overwhelming as you grow. Kubernetes transforms this operation into a well-oiled machine, automatically handling these tasks and responding to changes in real time. Here are the key capabilities of Kubernetes. Automatic scaling. Kubernetes automatically adjusts your application capacity based on demand, like a restaurant that can instantly add or remove tables and staff as needed. It's self-healing. When something fails, Kubernetes automatically restarts or replaces the failed components, eliminating the need for manual intervention at 3 a.m. Intelligent load distribution. Traffic is automatically distributed across all available instances, ensuring optimal performance and resource utilization. Seamless updates. Applications can be updated without downtime, with automatic rollback if problems occur. Infrastructure flexibility. Applications become truly portable, running consistently across any cloud provider. So to help us understand Kubernetes, let's create a simple application and containerize it. Now this is different from our Zephyr application. We're just going to create a simple hello world. So I'll just make a directory, and then we'll go into the directory. And then I'll just initialize a simple Node.js application with npm init. Okay, I got open up Visual Studio Code. I'm just going to create the main file. Again, this is just a simple example. I'm creating this simple app. I'll install the dependencies, Express. Now I'll add some new scripts to the package.json. Got to start and dev. And then I'll just start the application with npm start. And I'll go to this URL here. And we can see it says hello world here. So this is the basic application that we want to containerize. So next we're going to have to create a Docker file. So it's just going to be called Docker file, no extension or anything. Let's talk about Docker for a minute. Docker is essentially your packaging tool. It creates standardized containers for your apps. Think of it like a shipping box that includes your app and everything it needs to run properly. The best part? These containers run exactly the same way everywhere, whether on your laptop or in the cloud. Now Kubernetes comes into play as your management system. While Docker handles individual containers, Kubernetes is responsible for managing multiple Docker containers at scale. It handles all the complex tasks like deployment, scaling, and monitoring. You can think of it as a smart container orchestrator that keeps everything running smoothly. So why do we need both? Well, it's simple. Docker and Kubernetes serve different but complementary purposes. Docker takes care of packaging individual apps, while Kubernetes manages multiple Docker containers. They work together seamlessly, just like in a restaurant, where Docker is the kitchen preparing individual meals, and Kubernetes is the manager making sure all orders are coordinated and delivered efficiently. So let's talk about this Docker file. It's our basic application that we want to containerize. It's a set of instructions that tells Docker how to package our application. So first we have our base image. This is like a recipe that starts with the base operating system. And then we have our working directory. Now it's good to have your application. You don't want to use your root as the main application. So in fact, let's actually create that directory. And then I'm going to move my app.js into that directory. And then we're going to copy our package.json and package lock, that's why I have the asterisk here, into our container. And we want to install the dependencies, which is going to include Express in this situation. And then we'll just copy the rest of the application. And then we tell Docker which port our app uses, and then the command to start our application. And let's make sure we update our package.json now that we moved our app.js to the app folder. And then in my Docker file, I just have to make sure we have app/app.js for our new location. And now we can build our container using Docker. So before we build our container, you're going to have to make sure you have Docker desktop running. Now, the way to install it is different depending on your operating system. So just search for Docker desktop and just get that installed and running. So once we got that running, we can do docker build -t hello KAS, our directory version 1, and then the dot. This command takes our Docker file recipe and creates a Docker image. It's like a template that can be used to create running containers. Now let's talk about pods. A pod is the smallest deployable unit in Kubernetes. Think of it as a wrapper around one or more containers. Pods are like tiny virtual machines that run your containers. So I'm going to create a pod manifest. I'm just going to create a new file, and it's going to be called hellopod.yaml. And then I'm just going to paste this in. So we have the name of our pod, we have the containers, so we've named the container hello container, and the image is the one that we just built, and then we put the port that our application uses. This YAML file basically just tells Kubernetes how to create and run our pod, basically like a blueprint for running our container. Now we need to deploy and verify. So to deploy, we are going to be using the kubecontroller command. So I'm just going to type in kubecontroller to make sure it's installed. If you don't have that installed, you can search for how to do that. And also we have to have Kubernetes running on our machine. So there's a few ways to do that, but if you have Docker Desktop installed, the easiest way is just go to Settings, you go to Kubernetes here, and then click the Enable Kubernetes. Now this is already enabled. Once you click this for the first time, it's going to take a few minutes to install and get running. So since I already have Kubernetes enabled, I can now start running the commands to deploy the pod. Now we'll do kubecontroller apply -f hello-pod.yaml. So we create the pod. So in Docker Desktop, we can see that the pod is running. We can also check if the pod is running on our terminal. So I'll do a kube controller get pods, and then we can see it's running. We can also get detailed information with kube controller describe pod hello pod, and then we can see all this additional information about our pod. So if I just make this bigger, so we can get a lot of information about what the pod is like. Let's just test it out. So if we do curl and then the localhost 3000, it should say hello world, right? Well, no. That's because we are outside of the pod, so the localhost only applies inside the pod. So temporarily, we can actually port forward. So I'm going to run kube controller port forward hello pod 3000, and now it's forwarding everything out to our computer here. So we can open up a new terminal, and then we can run the curl localhost, and we can see hello world there. Now the port forward command is just like a temporary connection between the local machine and the pod, and it's useful for testing and debugging, but it's not a production solution. In production, you typically use a service and possibly an ingress to expose your application. So let's just close all this down for now. Now let's talk about creating a deployment. Pods are great, but they have limitations. If a pod crashes, it won't automatically restart. So this is where deployments come in. Deployments manage multiple copies or replicas of your pods and ensure they're always running. So let's create a deployment manifest. So I'm going to create a new file, not there though. I'm going to create a new file at my root, and it's going to be called hello deployment.yaml. Okay, so this deployment is going to run 3 copies of our application and make sure they're always running. So if any pod fails, Kubernetes automatically replaces it. And it's looking for the pods that are called hello KAS, which we created. And then we specify our container and image. And now let's deploy it. So I'll do kube control, apply, and then the hello deployment.yaml. And then we can watch the pods being created with kube control get pods-w. Okay, so now you can see we have all of these created. While deployments manage our pods, we still need a way for users or other applications to access them. So this is where services come in. We're going to add a service now. So why do we need services? Well, pods are temporary. They can be created and destroyed at any time. And each time a pod is recreated, it gets a new IP address. Services provide a stable, unchanging way to access your pods regardless of which pod actually handles the request. Think of a service like a front desk at a hotel. You don't need to know which room or pod you're going to. The front desk or service handles that for you. So let's create a service manifest. So I'm going to create a new file called hello service.yaml. So let's break down what this service does. We have the selector. This tells the service which pods to send traffic to. It matches the labels we set in our deployment. The port, which configures how traffic should be routed, and the target port, the port on the pod to forward to. And then we have our load balancer, which makes our application accessible from outside the Kubernetes cluster. So let's deploy and verify. We'll do a kube controller, apply hello service.yaml, and we'll save first actually, and then we'll run that command again. Now we'll check the service status with kube controller get services. And now that I have that service running, we don't need the port forwarding. I have this other terminal here, and I can do curl localhost. I don't need to do port 3000 anymore because it's listening on port 80, which is basically the default where we don't have to put in a port. And then we can see message hello world. Okay, let's get rid of that. And let's talk about ConfigMaps and Secrets. So as applications grow, you'll need a way to manage configuration and sensitive information. Kubernetes provides two resources for this. ConfigMaps, they store non-sensitive configuration data like environment variables or configuration files. It's basically a way to keep application settings separate from your application code. Then also we have secrets, which are to store sensitive information like passwords, API keys, certificates. It's similar to ConfigMaps, but with extra security measures. Data is encoded, but not encrypted by default. So let's just see really quick how you would do that. Let's create a new file just called hello.config.yaml. And then this is how you would set up that. We are going to have data with a message, hello from ConfigMap, and then we can access that message. And then if you're going to create a secret, I'll just create a new file, hello secret.yaml. And this is how we would save our secrets. So a kind of secret data. Now this is just a made up API key, but so this is just for demonstration purposes. And to use our config map and our secret file, we would update our deployment file. Basically in our spec, in our containers, we're just going to add some information at the end here. We have env, and then we are creating a variable. We're creating an environment variable from the config map, and then we are creating an environment variable from the secret. We're getting from hello config, hello secret, and the key. So now we can access that within our container. And then we can just run the kubecontroller apply-f hello deployment.yaml to add those configuration variables. Now that we have everything set up, we can verify everything. So we can run kubecontroller get all, and this will show all resources and the namespace. And then we can get the service URL. We can, with kubecontroller, get service hello service. We can get the URL there. We can view application logs by first getting the pod name with kubecontroller get pods. So we have all these pods, so we can then view the logs. Kubecontroller logs hello pod. So then we can see the logs running. So basically this completes our introduction to Kubernetes fundamentals. Each component we've covered, pods, deployments, services, config maps, and secrets, play a really important role in running applications in Kubernetes. Understanding how they work together is key to successfully deploying and managing applications in a Kubernetes environment. Okay, now let's see how these basic Kubernetes concepts are implemented in more of a real-world application. So let's just break down the application architecture of this Zephyr app. There is the front-end layer, which is a TypeScript-based web interface and has client-side routing. We got the back-end services, which is a Java-based microservices handling core business logic, and we have the RESTful API interfaces. And then there's also the supporting services, which are Go-based utilities and helpers. We have infrastructure monitoring and service mesh integration. So there's a few ways it could be deployed directly to Kubernetes clusters or to Amazon EKS, which will be our primary focus. So I introduced this Zephyr retail store application, and let's see how it uses the Kubernetes concepts that we just learned. So I'm in the Zephyr app. I'm in deploy.yaml under this deploy Kubernetes folder here. And this is a microservice-based retail store that demonstrates how real enterprises use Kubernetes. So it's broken up into a bunch of different microservices components, a UI service, catalog service, cart service, order service, and a few more. And we start by having these namespaces. So unlike our simple example earlier, real applications use namespaces to organize different components. So here we have the assets namespace, the carts, catalog, checkout, and then we have a few other namespaces here, and that's what this is all starting with. Oh, I guess to here, the UI namespace. And then we have the RabbitMQ namespace. The separation helps with resource isolation, access control, clear service boundaries, and easier monitoring and maintenance. And then we have these different services account, which basically correspond to the different microservices. Now let's look at how the UI service uses config maps for configuration. So before I showed you the config map in a different file, a lot of the things that were in different files can all be in one file. So we have this config map here, and there's a few different config maps. So we have the assets, carts, catalog. I'm actually gonna focus on the UI one right here. This config map shows how service discovery is handled through internal DNS names, and each service can be configured independently, and environment variables are managed centrally. And then we also have our secrets in here, basically for sensitive data. So we have our database credentials and just other different secrets that we have right in here. Then we have these services. So services are used to enable communication between components. So each service has a consistent naming pattern. It uses the cluster IP type right here, and the UI service uses the load balancer type for external access. If I go down there, so here's the load balancer type. And then we have the deployment. So let's again look at there's a deployment for each of the sections, but let's specifically look at the UI deployment. So there's some key enterprise patterns shown here. So we have the resource management, which is a best practice. We have this security context. And then we have the health monitoring. So to cover all the details on this is a little outside the scope of this course, but I just wanted you to see what it looks like. So let's see how we would deploy this with Kubernetes. So let's go into the Kubernetes directory. So cd deploy, cd Kubernetes, and I will just take this off. And we have our Docker desktop still running with Kubernetes. We have the kube controller installed and configured. And so now let's check our cluster connection with kube controller cluster info. So this basically checks if our Kubernetes control center is up and running. It's similar to checking if you have internet connection before you're trying to browse the web. So we have it running, which means that we have it running on the Docker desktop, and then we can start to move forward. We're going to create our namespaces. So basically we're using our deploy.yaml file. It includes namespace definitions, and we're going to verify they're created. So we'll do kube control, apply, and then the deploy.yaml. Okay, so we just created all this from our deploy.yaml file. And then I'm going to verify they're created by kube controller get namespaces, and I'm looking for the specific namespaces we know are in there. Okay, so we found all these namespaces. Now let's check what's being deployed by verifying the resources. So kube control get deployments all namespaces. So now we can see everything, including our hello deployment that we did previously. Now we can check our services, kube controller get services all namespaces. So here's all the services that were included in our deploy.yaml file. And then we'll check our pods. So it looks like most of them are running. We do have some that the status is not running. We can also check the UI access. The UI service is exposed via load balancer. So kube controller get services UI-LB, and we can see that this is the external IP is pending right now. Now we can check our pod status with kube controller get pods -s all namespaces, and then we can look for running. Well, so anything that's not running. So here are the ones that are having some problems. Now, some errors can happen if you have multiple apps that are running on the same port. For instance, I have the Hello World app that I created earlier in this tutorial. So to remove everything from that app, I can do cube controller delete all, and then everything in the default namespace. Now, it would normally show everything here that we created earlier, but I've already run that command, so it deleted everything. And then after everything is deleted, you can make sure to run the deploy.yaml, apply that again to make sure everything's set up. We can't quite get it running locally yet because there are a lot of required images that we would have to pull down. Like, these are all these required images that it needs for this application, and we could pull them locally to our computer to run it locally, but I'm not going to do that for now. But later we will get this up and running. Elastic Kubernetes Service, or EKS, from Amazon is a managed service that makes it easy to use Kubernetes in the cloud without worrying about the complex infrastructure setup. Instead of spending time installing, operating, and maintaining your own Kubernetes control plane, AWS handles all that for you. It's like having AWS as your Kubernetes expert team that manages the complex parts while you focus on your applications. With EKS, you get a production-ready Kubernetes cluster that automatically handles many critical tasks, like system updates, security patches, and scaling. The service seamlessly integrates with other AWS tools and services, making it easier to deploy, manage, and scale containerized applications using Kubernetes. EKS clusters are built on 3 core components. First, there's the AWS Managed Control Plane, which handles all essential Kubernetes services like the API server and schedulers. Second, you have node groups, the servers running your applications, available as managed, self-managed, or serverless Fargate options. Finally, the networking layer connects everything through your VPC, using security groups and load balancers to manage traffic securely. We also need to understand infrastructure as code and why we're using Pulumi. What is infrastructure as code? Well, infrastructure as code means managing your infrastructure through code rather than manual processes. Instead of clicking through the AWS console or running commands manually, you write code that describes your desired infrastructure state. Key benefits of infrastructure as code are reproducibility, which is to create identical environments every time, and version control, where you can track changes and roll back when needed. Automation, eliminate manual steps and human error. Documentation, code serves as living documentation. And scalability, you can easily replicate infrastructure for different environments. So why should you choose Pulumi for application deployment? Well, Pulumi modernizes Kubernetes deployments by replacing complex YAML manifests with familiar programming languages like Python, TypeScript, or Go. This allows developers to use standard programming concepts and tools they already know, leading to more efficient infrastructure management and faster deployment cycles. Unlike traditional infrastructure as code tools, Pulumi leverages existing programming knowledge and development practices. Its stack concept simplifies managing multiple environments while automatically tracking resource dependencies. The platform also extends beyond Kubernetes, allowing management of resources across multiple cloud providers in a single program, making it an ideal choice for modern application deployment. We're going to use Pulumi to deploy our Zephyr application on EKS. But first, let me just do a another quick overview of Pulumi. I'm gonna create a really quick demo Pulumi project so you have a better understanding how Pulumi works, and then I'll show you how we use Pulumi to deploy the Zephyr application. So first we have to make sure Pulumi is installed. If you have Mac OS, it's brew install Pulumi/tab/Pulumi. And if you are on Windows, it's Choco install Pulumi. And then we need to configure Pulumi to access our AWS account. If you have AWS installed, then Pulumi, and if it's already configured, Pulumi will just use the configuration settings that you use for AWS. So I need to get my AWS access key. I'm logged into AWS. I'm going to go to security credentials, and then I'm going to create an access key. This is not best practice, but it's the fastest way for now. So I have my access key, and I can export this as an environment variable, just all capital letters with underscores, AWS access key ID, and then I can also do AWS secret access key for environment variables, or I can just do AWS configure. So I'm going to put in my access key, and then my secret access key. And then for my default region, you can use whatever region you want. I'm doing US East 1. And again, we could have set these as environment variables if you don't have the AWS CLI installed, or if you plan on using Pulumi in a CI/CD pipeline. So I'm now going to create my project. So first, I'm just going to be calling this Pulumi Quick. And I'll go into the directory, and then I'm going to do Pulumi new AWS JavaScript. So basically, this Pulumi new creates a new Pulumi project with some basic scaffolding based on the cloud and language specified. So now I have to enter my access token to just get logged in to Pulumi. You may not have to do this if you're already logged in. So I'm going to log in to Pulumi, or I could create an account, and I'll create a token. Okay, I'll copy the token and then just paste it in here. Now this will help us create our project name and everything. I'm just going to use these default items. I'll use npm, a default AWS region. Okay, it's setting it up. Okay, let's review some of the things that were generated here. We got the index.js. So this is the Pulumi program that defines our stack resource. So we're getting a AWS bucket called myBucket. We're exporting the name of the bucket. So when we deploy the stack, this will provision the S3 bucket. And then we have the Pulumi.yaml, which is going to just give some of the configuration options. So now we can just go ahead and deploy the stack with Pulumi up. So this command evaluates the program and determines the resource updates to make. First, a preview is shown that outlines the changes that will be made when you run the update. So then I have to say if I want to perform the update. And once the preview is finished, we're given 3 options to choose from. Now, if we had chosen details on that last prompt, it would show a rich diff of the changes to be made. And the output here is going to be what we see here, the stack output. And we can see that we now have a bucket name in our output. That's the S3 bucket that we created up here. Now we can access the outputs from the CLI. So I can do Pulumi stack output bucket name. And then we can see the bucket name again. And now we can actually see the bucket in a few different spots. Well, I'm going over to AWS, go to my S3 buckets here. And then here's the bucket I just created. And then if I go to the Pulumi website, I'm logged in, and I'm on Stacks and then Pulumi Quick, the one I just created. So we can see our bucket on here. We can see the bucket name and information about the bucket here. Okay, now that the bucket is provisioned, let's just quickly modify the program to host a static website. So I'm just going to create a new file called index.html, and then it's just going to say hello everyone. So now I'm going to go back to index.js, and we're going to add that file to the bucket. So right after creating the bucket, I just added how to create an S3 bucket object. So we have the bucket object, which is the index.html, and it's going to get this source, the file asset, the index.html, and to the bucket into the ID of the bucket. Now, this bucket object is part of the bucket we deployed earlier because we referenced the bucket name in the properties of the bucket object. So we refer to the relationship as the bucket object being a child resource of the S3 bucket that is the parent resource. That's how Pulumi knows what S3 bucket the object should live in. Next, we'll just deploy our changes. I'll save it and then just do Pulumi up. And then we will see that we have +1 to create. We'll preview the changes. I will go to yes, I do want to perform this update. And it's just going to proceed with the update and upload the index.html file to the bucket. Now we can verify the object was created in the bucket by a few different ways. Over on the AWS console, we can now see the index.html file is in here. We can also use the AWS CLI, AWS S3 ls, and then we would put the bucket name right here. And it's going to show us our index.html is there. Now let's update the program to turn the bucket into a website. So I'm going to add one more thing to our index.js file. After we update the file, we now are creating a website. Bucket website configuration v2. So this is how we set this index.html as the index document of the website. And for the bucket object itself, we'll need a few more resources. First of all, before we define the bucket object, I'm going to put in some ownership controls. We have the bucket ownership control resource, which will define the bucket's file ownership settings. And we are defining as object writer. And we're also going to need, I'm going to add one more thing here, a bucket public access block. And this is going to allow our bucket to be accessed publicly. And then inside our bucket object, I'm going to add some additional stuff here. We need an access control setting of public read to allow the page to be accessed anonymously, like in a browser, and a content type of text HTML to tell AWS to serve the file as a web page. And note that the bucket object also includes the Pulumi resource option depends on. This setting tells Pulumi that the bucket object relies indirectly on the bucket public access block, which is responsible for enabling public access to its contents. If you omit the setting, the attempt to grant public read access to index.html would fail, as all S3 buckets and their objects are blocked from public access by default. Finally, at the very end here, we're going to export the resulting the bucket's endpoint URL. So this is going to export the URL so we can browse to it easily. So I'll save this, and I'll go back into the terminal and do Pulumi up. Okay, looks like I did something in the wrong order. Can I access website before initialization? So this website, it's actually a reference here. I put it in the wrong order. So let me just move that up to here. And then we'll do Pulumi up again. And I will perform this update. Okay, and it's going to output this URL. So let's go to the URL. And it works. Hello, everyone. Okay, now that we've seen how to deploy changes to our program, let's clean up and tear down the resources that are part of the stack, so we can very easily destroy all the resources. So I'm just going to do Pulumi destroy. And then it will basically remove the bucket and remove everything that we did. So we won't be charging all this extra stuff to our AWS account. And then we can delete the stack. If we know we're never going to use this again, we can delete it completely, and this is going to remove the stack entirely from Pulumi Cloud along with the update history. And I'll just confirm that I want to delete it, and it's been removed. So I'm back in my Zephyr application, and then the infra folder for infrastructure, we have the index.ts, and this is the configuration for Pulumi to deploy this application using Kubernetes to EKS. So I'm just going to go over this. I'm not going to go over everything in detail because it's a very long file, but I'm going to go over the key sections so you have a better understanding how Pulumi works in a more complicated project. Before I go through this file, I just want to briefly discuss some of the things that make creating infrastructure this way easier compared to using YAML files. So I have the Pulumi extension installed, and one thing that allows me to do, well, watch this. I can do const cluster equals new, and then I can use the IntelliSense suggestions for resource options. And then if I just hover over here, I can see these inline documentation that allows that shows me the different things I can create the cluster with. And we can also get code completion if you have that in your code editor. So I can just tab that and put that all in there. Plus, I get type checking to catch errors, and this way makes infrastructure more discoverable. Okay, well, let's review this file. So we start with the imports, which are the necessary packages, plus we have the tools like EKS and Kubernetes that are going to help us. We can work with those in the file. And then we have our cluster configuration variables, which define how big the cluster can be, the minimum, maximum desired number of nodes, and they can be customized through Pulumi's configuration systems. Then we have the network setup that creates a virtual private cloud, basically a private network in AWS where your EKS cluster will live. Then we have the EKS cluster creation, which specifies where it should live, the VPC, and how it should be configured. Then the rest of the file defines the various Kubernetes resources, basically the same resources that we talked about earlier in the course. But first we have some labels, which are basically key value pairs attached to Kubernetes objects for organization and selection. These help with identification, grouping, and selection. And then we have the namespaces. These are just like we saw in the Kubernetes section of the course. So we're just having code to create all the same namespaces in Pulumi. And then we have our service accounts, which provide identities for pods, allowing them to interact with the Kubernetes API and other services securely. And then if we keep going down further, we are going to have the config maps. So the config maps store non-sensitive configuration data that can be used by pods. And like we talked about earlier, they're for environment variables, application settings, and service endpoints. And then after the config maps, we are going to have the secrets. So that's for stuff like database credentials, API keys, authentication tokens. And then we have the services. Again, just like we saw in the Kubernetes section, these provide network connectivity between pods, load balancing, service discovery, and external access when needed. So if I go down a little more, and then we have a place to build the assets images and the different images we're going to need. And if we go down more, we can see how we're going to create deployments. So deployments we discussed earlier. And these are going to manage the number of pod replicas, rolling updates, pod templates, health checks, and resource limits. So for instance, we have this liveness probe. This is a health check. It ensures containers are healthy and automatically restarts unhealthy containers. And then we have the resource management. This controls the CPU memory allocation, prevents resource exhaustion. Then we have the security context. It enforces security policies, runs containers with minimal privileges, and implements security best practices. We have the volume management, which provides temporary storage, manages persistent data, and handles shared storage between containers. And then a lot of the rest of this is just the different deployments that we're going to use for the different microservices. So again, going into all the details is beyond the scope of this tutorial, but this configuration provides a complete production-ready microservices application with proper separation of concerns, secure configuration management, resource optimization, health monitoring, and scalability support. And you can get the link to the code in this video description. But now that we've gone over this, let's see how to deploy it. So let's go back a little bit and then go into the infra directory. Oh, you need to go back one more. Okay, we're in the infra directory. And now I'm just going to do npm install to install all the necessary dependencies. And then we'll do Pulumi stack init dev to create a new stack, the dev stack. Now we already have AWS configured from before, so I can just do Pulumi up. And I say, yes, I want to perform the update. Okay, that finished. So I'm going to get the kubeconfig, which is basically like the key or the password to access this cluster. And then after I put it into this file, and then I can run this command basically to get the application URL. So this UI here is the namespace. This UILB is the service. And that should give me the URL here. So here's the URL to access the program. We could also get this over on the AWS website. Okay, and here we finally get to see what the website looks like. So we can go around to home. We got the catalog, and this is all being hosted on EKS, on AWS. We can check out here. We finally got this all live using Kubernetes and EKS, and also Pulumi. Now let's get our Hello World application deployed to EKS using Kubernetes and Pulumi. So I've created a GitHub repo. Now I'm logged into Pulumi. And I'm going to use Pulumi Copilot to help me get this deployed. This allows us to basically use a conversational chat interface to do a lot of different things, like generate infrastructure as code and a bunch of other things that we may want to do. So I'm going to try it. I'm in settings, and I am going to enable this. And I'll just click this star thing to open up Pulumi Copilot. So I'm going to just tell a Pulumi Copilot, just type this in, help me deploy my application to EKS with Pulumi. I have already created it locally, but have not created a Pulumi project yet. What are the steps? And then I'm going to just say, here is my Docker file. So it just knows a little bit more about my application. And then I will press the send button. So it says install the Pulumi CLI, create a new project with Pulumi new TypeScript, and then it gives you some more steps here. Before we keep doing this, I can ask it more questions. Like from experience, I know that Pulumi new TypeScript is going to overwrite my package.json, which I don't want to do. So I can say, won't Pulumi new TypeScript overwrite my package.json file? I don't want to do that. Okay, so now this is how we do it without overwriting your existing files. So I will copy that, and I'll paste the command Pulumi new generate only TypeScript, and I will do force. And then we can just go through, and I'm just going to set up the new Pulumi project. I'm just going to use all the default settings, npm. Okay. And our package.json is still correct, but we now have the pulumi.yaml. We have the index.ts, which we're going to be adding to. So let's go over the next step. Install the Pulumi packages. Now we should have these already, but I'm just going to do it just to make sure. So we'll paste in the packages to install. Then create a new file, the index.cs, and set up your EKS cluster and application deployment. So I'm just going to copy all this. And then we'll just paste in here. Let's go over this a little bit. So we are creating our EKS cluster. We are exporting the cluster's kubeconfig to help configure everything. And then we're creating a label, my app. We're deploying it. Now we can see here, we are loading our application from this image on Docker Hub. So that's something that I haven't talked about. Docker Hub is a container repository. We can see here that it recommends build your Docker image and push it to a container registry. So not a repository, a registry, like Amazon ECR or Docker Hub. So there's a few different ones you can use. We are going to use Docker Hub because it's a little easier for your first time. But here's why they're required. When deploying applications to Kubernetes, which includes EKS, you need a container registry. And some of the reasons are because Kubernetes needs to pull your application's container image from somewhere accessible to the cluster. And you can't directly use the local images in a remote cluster. So when we did the example before, we were using a local image, but it's not like it can pull it from our computer. So we have to put it on some registry. And container registries provide a centralized, secure location to store and distribute our container images. So Docker Hub is free for public repositories, and they do have a free tier that we can use for this. So I'm at hub.docker.com. You can either sign up or sign in. I'll just sign in with my account here. When you create your account, you will create a username. And that's what we need to put in right here. So my username is just my name. And we can see it says container port 3000. That is the port that we have in our file. We can go to our Docker file and we can see that we're exposing port 3000. It's also the port that is right in our app.js file. So let's go back to our Pulumi file, and we can see we've also have a service with a load balancer. So the load balancer is how you get access to your actual URL. When you're using Pulumi, truthfully, you don't have to do a lot of manual coding because you can have the AI just write it for you. So now we can keep following these instructions here. We'll have docker build -t my app. Now we previously ran this command and we called it hello-ks v1, but this time we'll just build it again with a different name so we can kind of go along with these instructions here. And this now it's going to be called my app. And I do have Docker desktop running in the background. That's important. The command won't work if you don't have Docker desktop running in the background. So now that we've built it, we are going to get it uploaded basically to Docker Hub. So I'll copy this next command. So first we have to do the Docker tag, then we do the Docker push, and I just have to make sure to put in my actual username. And then we can see this is called bocarn/myapp latest. So that's why it's going to look exactly the same here. So now I just do the same thing with Docker push. Okay, it wasn't the exact same thing. It's Docker push. I don't need the my app anymore. So Docker push bocarn/my app latest. Okay, while this is pushing to Docker, let's go look at our next step. Now we just have to run Pulumi up. And that should actually just deploy the application to EKS. It says it will create the EKS cluster, build and push our Docker image, and deploy our application to the cluster. And we can then access the application via the load balancer URL created by the Kubernetes service. So let's do Pulumi up. And we'll just wait for it to do everything, create everything in the background. And we got an error, but that's okay because we can just go right over to Pulumi Copilot, put in here, and then it should be able to fix. So it says it's unable to find a matching VPC in your AWS account. You can resolve this either by specifying an existing VPC or creating a new one as part of your Pulumi program. And then it will show how to create a new VPC and use it for the EKS cluster. So let's do that. We'll just copy this code over, create a new VPC. So we'll do that at the very beginning here. And then it says update the EKS cluster configuration to use the newly created VPC and subnet. So I'll just copy that. And I can just paste in the new EKS cluster, how to create the cluster. And now it just says to run Pulumi up again. So Pulumi up. And this time we have no errors, and we can say that we want to perform the update. Okay, we have a few more errors. We can just go back and forth a few times so we get this all fixed. Okay, after going back and forth with the AI a bit and adding the service IP so we can access, so we have the web address to access, everything works. So I'm going to just test it out. I can just copy this service IP here, and it works. Hello world. So I've used Pulumi to deploy to EKS on AWS. And I want to go over a few other things when you're using Pulumi. One is the drift detection. So Pulumi offers drift detection, which is the process of identifying changes in the actual state of your cloud environment that are different from the expected state stored in the Pulumi cloud. So it's really easy. You just do Pulumi refresh, and then it's gonna compare what's on your actual cloud on AWS with what Pulumi thinks, and then it will just fix everything. For drift detection, when you do refresh, no resources will be modified, just the stack state will be. So the Pulumi information will basically start corresponding to what's on our cloud. In this case, it was all unchanged. Nothing was different. And if you're going to be using Pulumi a lot, you should consider installing the Pulumi extension for VS Code or whatever code editor you're using to get code completion and be able to mark errors more easily. So I can just go to Pulumi and then Pulumi tools for VS Code and install. Another thing I wanted to quickly review about Pulumi is their Insights feature, which is an intelligent infrastructure management service that will help you discover, understand, manage, and improve your cloud infrastructure. Basically, it can help you understand your cloud infrastructure with AI insights, even things that you didn't even previously tell Pulumi about. So let me just show you how that feature works. For the account discovery, it requires read-only access to your cloud accounts, and that's granted by creating an ESC environment that generates valid credentials for the corresponding Pulumi provider when accessed. So I'm going to go to this Pulumi ESC here and environments. I'm going to create an environment, and then I'll just call this Insights environment. And I'll use the same thing for the name. And now we're going to need to configure Pulumi Insights with AWS. Or if you have another cloud like Azure or something else, you can configure with that. So I'm on the AWS console. I'm going to go to the roles page, and I'm basically creating a new role. So I'll click the create role button, and then we'll do web identity. And then for the provider, I'm going to do create new, and it's going to be an OpenID connect provider. So api.pulumi.com/OpenIDConnect. So the audience, it's going to just be AWS, and I put colon, and then the name of our organization on Pulumi. Now you're going to have to be a admin for your Pulumi organization to even get this set up. So the organization name is just FCC for freeCodeCamp. And then I'll click add provider. Okay, I can close this, and then I'll just refresh this page. So now I should be able to do web identity, choose a provider, and it's going to show the Pulumi provider now. Now for the audience, the AWS FCC, and then we'll go to next. And then for permissions, I'm going to filter this to read-only access. And then I'll go a little further forward in the search results, and we'll just go to read-only access. So nothing before the read-only access, just like that. And then I'll go to next. And then for role details, I'll just put Pulumi Insights, or I guess I can't put a space. So Pulumi Insights, and then I can do create role. And then I can just go into this role to see more information about it here. And now we're back over at Pulumi, and we can update this environment definition with our cloud credentials. So I'm just going to paste over this, and then we're just going to update this. For my role ARN, I can get this ARN here, and I'll just select this and paste it in here. And then we can just delete some of this example code down here. If I scroll down, we have another example that we don't need. And I'm going to save this. So now that we've set up the ESC and the cloud account, let's create the Pulumi Insights account and do a discovery scan. So we have this Pulumi Insights section down here. So I'll click Accounts, and then we can create an account. I'll choose AWS for the cloud service provider. And then the ESC environment, the one we just created. The account name, we can basically provide any unique name. So I'll do Insights AWS. And then we can basically select where we are scanning, which is for me, it's the US East 1. And then we can do automatic or manual scans. We'll just keep with the manual scans, and I'll do create. And then we have our account. I can go to the accounts tab, and we can see everything that's its access, which is just the US East 1. Go back into here. So basically, I just go to actions and then scan, and then scan. And that's gonna kick off a scan across each child account. So if there were other regions, it would be scanning the other regions as well in parallel. And then we just wait. The scan duration will depend on the number of resources for each account. And as soon as they're discovered, you can begin to explore the insights. You don't have to wait for everything to finish. So once a scan is finished on one section, you'll see the check mark. So we have this check mark here, and then it's still scanning this one. Then we'll see the other check mark once that finishes. Okay, now that the scan is finished, let's use Pulumi Resource Explorer and learn how to draw insights from the cloud infrastructure. So I'm going to go over to the Resources tab. And here are all our resources, including some of them that were found when we did the scan. So this offers multi-cloud search and analytics across every environment in the organization. Right now it's just one cloud, AWS, but if we were using different clouds, we could search for resources across everything. So I'm just going to click into this one, and then we can see information about this deployment. And we have access to statistics about cloud usage, including we have the breakdown by cloud type, or cloud provider, resource type, and department. And this search, we can just search by name. Let's say app. And then these say app. But we can also use AI. So we can search more with natural language. So I'm just going to use this suggestion one, show me resources in production. That was none. But what if I did a dev? And then now we got all the resources in dev, and it's going to show what syntax. It basically converted this natural language to stack::dev. Now put show me my VPCs. And then it's going to show the VPCs. And then it's going to show the query that it converted that to was type AWS EC2 VPC VPC. So this basically enables us to ask questions that will really improve the process for managing the infrastructure and getting answers to any key questions we have about our projects. And that's it. You should now have a better understanding of Kubernetes and EKS and how to use Pulumi to manage your infrastructure.